Okay, students, so we're here with the Pythagorean theorem again, but now we're going to do the converse. And what's the converse? We've talked about this before, but I'll elaborate later on in the video. All right, but let's apply Pythagorean theorem to the three triangles below. All right, the two smaller sides are A and B, and the longest side is C. So looking at this first one, what do we got here? Well, again, A and B don't matter which one's which. A, B. C, it has to be the longest one. So using Pythagorean theorem, a squared plus b squared equals c squared. We're going to get 9 squared plus 10 squared equals 15 squared. So we're going to get 81 plus 100 equals 225. And then, 181 equals 225. That's false. That's not true at all. All right, that's preposterous to think. All right, so Pythagorean theorem didn't work. I wonder why. I thought Pythagorean theorem worked. I'm kind of grouchy now. I've been lied to. All right, well, let's do this one. Now, A, B, C. Well, maybe that triangle was stupid. Maybe Pythagorean theorem is going to work on this one. All right, a squared plus b squared equals c squared. 5 squared plus 5 squared equals 8 squared. 25 plus 25 equals 64. What the heck is going on? 50 equals 64. Maybe on some other planet. Maybe Pythagorean theorem doesn't work. Maybe we've been lied to our whole life. Let's just try one more time, all right? All right, A and B are the smaller two sides. We got 8 squared plus 15 squared equals 17 squared. We're going to get 64 plus 225 equals 289, I think. Yep, 289. Oh, we got 289 equals 289. Whew. It worked. All right. Whew. Worked. All right. Now realize Pythagorean theorem only worked on one of these problems, or one of these triangles, and we should have known, we could have known that it would only work on this triangle on the right-hand side. Why? What did we notice? Well, you probably already knew this. You should have already knew this, but Pythagorean theorem only works for right triangles, right? It's only for right triangles. And if you're wondering why we've been talking about Pythagorean theorem right now, this unit is called right triangles. Unit 7 is all about right triangles. All right? So what does it mean if a squared plus b squared does not equal c squared? It means not a right triangle. All right? Now, looking at some things, so what's actually pretty cool and what we're going to elaborate on right now is we can tell what kind of triangle it is based on just side lengths. We can tell if it's obtuse, acute, all of that just based on side lengths without seeing any of the angles. And if a squared plus b squared is less than c squared, which is exactly like this first example, it's an obtuse triangle. All right, so if you utilize a and b as the smaller two sides, c as the biggest side, and this happens, we know it's obtuse. It has to be obtuse. All right. And then going right along, well, if a squared plus b squared is bigger than c squared, that was this middle example we did above, then it's an acute triangle. All right? Pretty cool. All right? Amazing. All right, so Pythagorean theorem, if a triangle is right, then a squared plus b squared equals c squared. That's the Pythagorean theorem. We're going to write the converse of Pythagorean theorem. And remember, the converse, a little bit of a review, swap order of hypothesis and conclusion. All right, so what does that mean? If the triangle is a right triangle, then a squared plus b squared equals c squared. So we're going to write if a squared plus b squared equals c squared, then the triangle is right triangle. We'll just write is right. Alright, so a little bit of review from stuff we did in Unit 2. We talked about converses a little bit here and there, but not too often. Alright, and now for double fund, we're going to write the biconditional. That's when something's true as in conditional form and converse form. We can write a very strong theorem, a very powerful theorem called the biconditional. And this is with the if and only if, also known as IFF, shorthand. But we can write a triangle is right if and only if a squared plus b squared equals c squared. Alright, and that's it. Alright, so that's kind of the intro to the lesson. Now we're going to do a lot of cool, fun things in the future.